the fifth point, and this point is going to be a random point. In this case, after 3.2, my pen's changed colour, mils of HCl has been added to the titration. Alright, so to do this point, we are going to need to do an ice calculation. So to do an ice, we start with the titration equation as follows, and then we're going to put in here all of our calculations, and we want to start with our number of moles. Right, so whichever point we're doing when we do this, we are going to put the initial is going to be, in this case, how many moles in 3.2 mils. We already had 15 mils of this to start with, and we always are going to just start with 0 over this side. So we need to convert these mils into moles. So N equals CV, so that's 3.2 over 1,000, that's our volume, and 0.0255 moles per litre. I'm actually just going to shift the C and this E down. So that, using my very bad calculator, 0.0255 times 0.0032 equals 8.16 times 10 to the minus 5 moles. 15 mils, again, we've got to do our N equals CV for a methanamine. So our concentration is the same, 0.0255 times our volume, 15 over 1,000. And that gives us, just tappity tap the buttons, 3.75 times 10 to the minus 4. Right, so from our equation, so I'm going to work in red now, we know that these things react in a 1-to-1 mole ratio. So only 1 mole of each can react, or 1 relative mole. So we need to react the smallest number. So we're going to subtract that many moles from here, and we're going to subtract the same number of moles from there, and then we're going to add the same number of moles to both of the products. Then we're going to do that subtraction or addition. So 3.75 times 10 to the minus 4, subtract 8.16 times 10 to the minus 5, leaves us with 2.934 times 10 to the minus 4. 8.16 minus 8.16 is 0. And 0 plus 8.16 is 8.16 times 10 to the minus 5. I'm going to ignore Cl minus because I know that Cl minus does not contribute to the pH. So I come to the point now, that's my E actually, that's my C there. C's the change, E's where we end up. And I come to the point now where I have got a solution with a mixture of a weak base and its conjugate acid. So going across to the next slide, to calculate the pH we still need to write a Ka expression for the weak acid, and this is the weak acid here. So CH3NH3 plus H2O goes to. Now the reason that we do this is it gives us an equation, a mathematical equation which has, Theo, stop it.
Sorry.
Which has both of the substances that we figured out that we have in our titration vessel. So we're going to write my Ka expression. Sorry about that, that was me getting grumpy, banging the table. So I'm going to write this Ka expression out. Okay, and now I'm going to substitute in my values and rearrange and solve. So just flicking back to slide 5, you do not have one source of your substances here. So you're getting the CH3NH2, and you're getting that from the base that you started with in your titration, and then you're getting the CH3NH3 plus from a separate reaction where that base reacts with the HCl. So we need to put both of these in, and we can't have an X squared in this case. So the Ka was given to us as 10.7 for the pKa. So we want to go 10 to the power of negative 10.7 to give me my pKa, sorry, to give me my Ka. And then my CH3NH2 is going to be 2.934 times 10 to the minus 4 on the previous page. My H3O plus is going to be my X, that's what I want to find, and my CH3NH3 plus is 8.16 times 10 to the minus 5. So now I need to rearrange and I need to solve for X. Right, so I'm just going to work through that now. Right, so the first thing I've done is worked out my Ka, which is 1.995 times 10 to the negative 11. And I'm going to multiply that by 8.16 times 10 to the minus 5, and then divide by 2.934 times 10 to the minus 4. And that gives me an X value of 5.55 times 10 to the minus 12. I'm going to negative log that to give me my pH. And that gives me 11.3. Okay, so we need to have a quick look just to make sure that this makes sense, because we can never do a calculation and not check that. So I'm just going to very, very quickly I'm going to draw my graph out. So my first point that I calculated, which is the pH at the start, is 11.6. So here is my 11.6. And my graph, excuse me, is, sorry about that, and my equivalence point is 6.3. And at halfway to equivalence point, I had 10.7. And then I had my asymptote line of 1.559. So my graph looked a bit like this. Okay. And what I would expect that after 3.2 mils, so that's 7.5, that's 15. 3.2 is about there. Then I would expect my pH to be between 11.6 and 10.1. It's a bit closer to 11.6 than it is to 10.1, but it is in the middle there, so I'm happy that this is the right answer.